Welcome to Section 20.1, Part 5. This is the 202nd session of the CISSP exam prep series. This part closes our tour of development controls with interfaces, testing, repositories, and acquired software. In this session, we'll cover how software talks to other software and how you verify and source it safely. We'll answer several questions. What security do application interfaces demand? How do you test software thoroughly and fairly? What testing philosophies can you choose from? How do code repositories help and endanger you? What do service agreements guarantee? And what changes when you buy software instead of building it? Why does this matter beyond the exam? Because modern systems are stitched together from many services and outside components, and each seam is a potential weak point. Picture an online retailer that leans on an outside payment service, a shipping integration, and a pile of open source code. Every interface, test gap, or exposed secret is a doorway. Knowing how to secure interfaces, test rigorously, guard repositories, and vet purchase software is what keeps that whole quilt from unraveling. What security do application interfaces demand? Modern web applications constantly talk to other services, and application programming interfaces let developers skip the web page and call the underlying service directly through defined functions. That power carries risk. So the first question is authentication. Some interfaces, like a public weather lookup, need none. But any interface that changes data, places orders, or exposes sensitive information must verify credentials and authorization on every single call. This is usually done with a complex API key passed along with each request, which the backend validates before acting. Treat that key like a password, storing it securely and sending it only over encrypted channels, because anyone who steals it can act as you. Tools like curl let developers post requests straight to an interface for testing, and attackers use the very same technique to probe it. Think of an API key as the badge that opens a staff door. Lose it, and a stranger walks right in wearing your identity. How do you test software thoroughly and fairly? Test everything before it ships, because testing is central to finding and mitigating risk. Design your tests as you design the modules, building datasets that exercise every path with known correct answers ready. Run a reasonableness check to confirm results fall within sensible bounds. So a routine that reports a human weighing 600 pounds fails immediately. Probe normal input, wrong types, out of range values, and edge conditions using both use cases that mirror ordinary activity and misuse cases that model an attacker. Never test with live production data early on, since a flaw could expose or corrupt it. And apply separation of duties by having someone other than the original programmer test the code, because a third party gives a broader, less biased examination than the author ever could. Think of it like proofreading. The writer skims past their own typos, while a fresh set of eyes catches them. What testing philosophies can you choose from? 3 approaches sit on a spectrum defined by how much of the internals the tester can see. White box testing examines the internal logic directly, stepping through the source code line by line to find errors, so the tester has full access to the code. Black box testing works purely from the outside, feeding varied inputs and checking outputs with no view of the internal code, which is how final acceptance testing typically runs. Grey box testing blends the two, examining the software from a user's perspective, while also using the source code to design smarter tests without analyzing the inner workings during the test itself. Think of inspecting a car. White box opens the hood, black box just drives it, and grey box glances at the manual before taking it for a spin. How do code repositories help and endanger you? Software development is a team sport, often with developers scattered across the globe working on different parts at once, and code repositories give them a shared home. Beyond central storage for source code, they add version control, bug tracking, release management, and communication features, and they integrate tightly with popular code management tools. But that convenience carries risk, and the first is access control. Some repositories are public by design, while others hold trade secrets and must stay locked to authorized developers. Grant read access too loosely, and outsiders can pull sensitive information. Grant write access too loosely, and they can tamper with the code itself. Think of a repository as a shared workshop. It only works if the right people hold keys to the right rooms. Why is leaking secrets into a repository so dangerous? Because a repository is only as safe as what developers put into it, and secrets do not belong there. The classic mistake is embedding an interface key, which is especially damaging with cloud providers, where a key can spin up servers and charge a real credit card. Push code containing such a key to a public repository, and anyone in the world can grab it, provision massive resources, and bill them to you. Worse, automated bots constantly scan public repositories for exposed keys and can pounce within seconds, long before the developer notices. The same caution applies to passwords, internal server names, and database names. Think of it as leaving your house key taped to the front door. It is only a matter of time before the wrong person tries it. What do service agreements guarantee? A service level agreement sets the level of service a provider commits to deliver, agreed by both sides, and it is wise to put one in place for any data circuit, application, database, or other component vital to staying in business. These agreements spell out concrete metrics, like system uptime as a percentage, maximum consecutive downtime, peak and average load, who handles diagnostics, and how quickly failover happens. They usually carry financial remedies too, so a provider who breaches the agreement, say by leaving a critical circuit down too long, might have to waive charges. Both sides monitor the metrics to confirm compliance. Think of it as a warranty with teeth, spelling out exactly what you were promised and what it costs the provider to fall short. What changes when you buy software instead of building it? Most enterprise software is purchased, not written in-house, and it comes in several forms. Commercial off-the-shelf software runs on servers you manage. Software as a service is delivered over the internet through a browser, with the vendor running it. And open source software is built by communities and freely available, often embedded inside commercial packages. The security responsibility shifts with each. When you install and configure software yourself, your team must understand its secure configuration and stay on top of patches. In a software as a service model, most responsibility rests with the vendor, but you are not off the hook, taking on the job of monitoring their security through audits and assessments, and often retaining legal compliance duties. Whatever the source, always test acquired software for vulnerabilities, whether through your own testing, vendor results, or independent third parties. Think of it as buying a pre-built appliance. Someone else did the wiring, but you still check that it is safe before you plug it into your home. So let's bring it together. Application interfaces need authentication and carefully guarded keys on every sensitive call. Test software thoroughly and fairly, with reasonableness checks, misuse cases, no live data early, and an independent tester choosing among white, black, and grey box philosophies. Code repositories power collaboration but demand tight access control and zero embedded secrets. Service agreements pin down measurable guarantees. And acquired software shifts responsibility yet always earns a security test. Master these, and every seam where your software meets the outside world becomes a controlled one. The MCQs covering all the topics and concepts from this session are available on rucloud.com. Practice the chapter-specific MCQs before moving on to the next session. Thanks for watching. If you have any questions or feedback, post a comment below or email us. I will see you in the next session.